All right, but before I jump into today's lesson, is there any questions anybody got? Everybody's good with the homework? All right. Everybody, you tried logging into the homework and you were able to get in? Right, right. Yeah, yeah. Yeah. Try logging in so it's your first name and then your last name, all lowercase letters as one word, no space, no dot in between. All right. But yeah, everybody's been good with the homework. No, it's not challenging. It's good. All right. All right, so let's look into our new lesson for today. Not gonna lie, this lesson's gonna be mighty easy. So if y'all want to do y'all homework in the meantime, go ahead. I am not mad. All right. Because the lessons are so easy, I'm always trying to search for like the most challenging questions to give y'all. But it's hard because the lesson is easy. You know, just bear with me 1 second, waiting for this app to open. Yeah, 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 yeah. Well, before you guys leave, just make sure y'all sign in real quick. I ain't going front. I look like somebody from the pantry right now. I don't know, but I look like someone. Hallelujah. All right, here we go. If it's not on the front, it might be on the back. There's a back side too. All right, so we're going to be talking about algebraic expressions. Cool, right? So all numbers are symbols. The number five is a symbol that indicates the quantity, answering the question, how many? More abstractly, the number five represents the quantity that all collections of five objects have in common. There are times when it is convenient to introduce other symbols that represent numbers. For example, you might read in an astronomy book that that light travels at a speed of nearly 300,000 kilometers per second. This is actually a rule that tells you that if you know how long a light ray has been traveling, you actually also know how far it has traveled. In 1 second, the light ray has traveled 300,000 kilometers, more than half the distance from Earth to the moon. In 2 seconds, the light ray will travel 300,000 times 2, which is 600,000 kilometers. In 750 seconds, which is 12.5 minutes, a light ray travels 300,000 times 750, which is 225 million kilometers, which is the average distance from Earth to the planet Mars. You might summarize this rule as follows. If t represents the number of seconds that a light ray travels, then the distance it will travel is 300,000 times t, or simply 300,000 times t, right? Remember the convention. When no operation is indicated, there is an assumed multiplication, right? So if you have two variables next to each other, it's assumed that they're going to be multiplied by one another, right? For our purpose, we will call a variable any symbol. We will always use letters, which is meant to represent a number whose value is not specified. A variable generally indicates that the value of the number is either unknown or, as in the example above, changing with time. Because of this, we will sometimes call numbers constants to distinguish them from the variables. All right. From this point of view, algebra will be the study of expressions formed by combining both numbers and variables by using the standard operations of addition, subtraction, multiplication, division, right? Numerical exponents and roots. The main feature which distinguishes algebra from arithmetic then is the use of variables. All right. So that's what we're getting into now. We're getting into algebra. All right. I know for a lot of y'all, this is really, really easy. Well, just bear with me. Again, this is all being recorded, so no worries. All right, convention. By far the most popular symbol to represent an unknown quantity is the letter X. Because of this, we will avoid using the symbol, this looks like an X, to represent multiplication from now on, right? So what I'm saying is, remember how we used to be like, oh, 2 times 3 is 6, right? I don't want to use that X symbol anymore, right? Because whenever I'm talking about variables, like say I want to do 2x plus 3 equals 6, right? It's a little confusing, you know? So other ways that you can use multiplication, there's a dot multiplication. So you can also say something like 2 times 3 equals 6. You can also put it in parentheses, 2, 3 equals 6. Those all mean the same thing, right? Just trying to show you guys some different conventions, right? It was there? Awesome. Okay. So if anybody else wants to sign up for pantry, go ahead. It's downstairs on the first floor. All right. Usually it's in low hall. All right. Something that you missed that I was telling them is that if you ever want to get like a free lunch in low hall room 411, they have frozen meals there, right? You can grab one, just go to the microwave, heat it up. So it's good food too. You know, I've heard good things about it. For real. Yeah, I've heard really good things about it. The reason why is because nobody here is making it. It's actually like food that's donated from like restaurants. That's why it's like really high end kind of thing. Yeah. 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 All right. 3.3, evaluating algebraic expressions. So given an algebraic expression, there is not much that we can do with it apart from identifying the variables and the operations involved in the expression. All right. Time for an example. All right. Mhm. All right, so let's look at an example. Consider the algebraic expression 3x squared minus 5x plus 4, right? This expression involves one variable, which is x, and 5 operations, right? An exponent, right? So our exponent is here. That's the square term that's right there. 2 multiplications. So you see how we have the 3 and then the x squared, that's a multiplication. And we have the -5 and the x, that's another multiplication, right? A subtraction, right? Here goes our subtraction right there. And an addition. Here goes our addition right here. Okay. Questions on this? We good? All right. So if on the other hand, we're given values for all variables appearing in the given algebraic expression, we can evaluate the expression. For those given values, we do this by substituting the given value at every instance of the variable. In the context of specifying values for a variable, we will use a shorthand notation with the equal sign, right? So for example, we will say evaluate an expression when x is equal to 1. This means evaluate the expression when x has a value 1. The use of the equal sign in the context is unfortunate because its meaning is very different from the way we use it in the rest of the book. However, like many unfortunate things, it is standard and we will use it in this section. All right. So let's look at another example. I want to evaluate 3x squared minus 5x plus 4 when x is equal to negative 2. All right. So this is how you do it. This is how you do it. All right. So I have 3x squared. Instead of the x, I'm going to write a parentheses. Minus 5. Instead of the x, I'm going to write a parentheses plus 4. Now, I want to evaluate this when x is equal to negative 2. So what does that mean? I'm literally going to take negative 2. I'm going to plug it into the expression right here. Negative 2, negative 2. And then after that, just do the math on it, right? So remember in PEMDAS, we do our exponents first, right? Or parentheses first, then exponents, right? So negative 2 squared, what is that? Positive 4, good. So now I'm going to rewrite this. This becomes 3 times 4 minus 5 times negative 2 plus 4. All right, help me out with this. All right. We want to go from left to right, doing our multiplication. What's 3 times 4? 12. Very good. All right. Minus, this is very hard now. What's 5 times negative 2? Very good. Negative 10. All right. And then just plus 4. All right. So now, right, what is the opposite of negative 10, right? Because that's what minus means, is that we want the opposite. So what's the opposite of negative 10? Positive 10, right? So this becomes 12 plus 10 plus 4. All right. Now this is the hardest part. We got to add all four of these numbers together. All right. What's 12 plus 10? 22. Very good. Very good. All right. Now what's 22 plus 4? 26. All right. Y'all all better get 100 on y'all first test then. All right. All right. Any questions on this? All right. I'll leave it up for a second. Oh, I didn't realize I wrote that big. I'm blind. That's why I did that. Huh? I'm not sure. I gotta work that out. Um, October maybe? Yeah. Wait, not October. Wait, what's the next month after this? March, March. Whoops. Oh man. Listen, don't ever put Bailey's in your coffee, you know? Well, that's terrible. Oh man. Yeah. And then the snow throwing me off too and all that.
So you said you add the 12 plus the 10 plus the 4?
Mm-hmm. Straight across, and that's it. So for those of you in the room that are considering switching out major to math, this is an important concept. Right? I know there's like three of y'all that's gonna switch to math in the future. I don't know who it is, but it's somewhere over here. Right? Yeah, because it's fun. You could be a teacher, you could research. Hmm?
Numbers.
Yeah. Or y'all could switch to engineering and do some other stuff. Mhm. A lot of things you could do. All right. I know some of y'all recognize this formula right here, right? Y2 minus Y1 over X2 minus X1, right? So now I want to evaluate this, all right? The Y2 and Y1, those are just names, right? And those names represent a particular number that you see here, right? So X1 is 4, X2 is -6, Y1 is -3, and Y2 is -18, right? So I want to evaluate Y2 minus Y1 over X2 minus X1. Tell me what to write. I want the numbers, not the names. What? Uh-huh. -18. Good, good, good. Minus. Very good. What about the bottom? Uh-huh. Very good. Good. Any questions on this? Everybody sees how I got that? No? Got you, got you, got you. So look, when in this original formula, right? The first variable that we have here is Y2. But instead of writing Y2, I'm going to write the number that's associated with Y2, -18. Right? And then the next one is Y1, for example, right? So I'm not going to write Y1. Instead of that, I'm going to write the number that's associated with Y1, which is a -3. All right? And then so on and so forth, right? So for X2, I'm going to write the number that's associated with the X2, which is -6. The Y2.
The Y2 equal
-18.
Okay.
Right.
And the 3 convert it into okay.
That's the Y1. Yeah.
Okay, and -18, -3
Mm-hmm.
over
Mm-hmm.
-6.
Correct.
4.
And then -4, right? That's the last one.
So and how I know I have to start with 18 and not with 4? How I know that?
Because the variables are named out right here in the original part.
Because the names are?
Yeah. So you see how it's Y2 minus Y1 over
Okay.
X2 minus X1? Yeah. Yeah. Right. So let's finish this real quick, then I'll do another one, right? So just want to do the math on this.
Okay. Please can you read it?
Yeah. Yeah. Mhm.
Okay.
What's that? Yeah.
So, okay, so it literally, so it's giving you the formula right there, right?
Mm-hmm.
And it's telling you Y2 is that subtract.
Y2, yep.
Y2
Minus. Mhm.
1Y over 2X minus X1.
Right.
Beta, okay, now this one I'm getting lost, right?
Mm-hmm.
So it's, is it gonna, like, say we have a test, right?
Mhm.
Is it gonna tell us exactly to evaluate,
Mm-hmm.
and then is it gonna give us the same
Exact same thing.
formation like this?
Mm-hmm. The formula over here,
formula.
that might change. That might look different.
Like,
Right. But all you're doing is just plugging in the numbers for it, and that's it. And then once you have all the numbers in it, you just do the math. All right. So the top says 18, -18, excuse me, minus -3. What's the opposite of -3? So I have -18 plus 3. And on the bottom, right, I have -6. What's the opposite of +4? All right, so plus -4. That's it. The rest of it is just basic math, right? What's -18 plus 3?
15?
Close. Give me a better answer. -15.
You said
-18 plus 3. Mhm.
oh, yeah.
So what's -6 plus -4?
Negative plus a negative is a positive, right?
No. Negative 10, right? Because I don't know why I wrote 16. Because you owe me $6, and then now you owe me four more, so now it's negative 10, right? Now a negative divided by a negative is a positive. Okay, okay. So now I have 15 over 10. Let's reduce that a little bit. Mhm.
What do you want?
Reduce it.
Oh, 15 is that one?
Not one,
3, 4.
not four.
So,
Say it again. Okay, so 5 could go into 15 and 10, right? How many times does 5 go into 15? Good. How many times does 5 go into 10? Good. So final answer, 3 over 2. And that's it. All right. Questions on this? All we doing is just plugging in the numbers, a little bit of math, boom, 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 and then we got our answer. No questions? Nah, because the top is negative and the bottom is negative. So a negative divided by a negative is a positive. Mhm.
I'm sorry, I'm sorry. No, I'm sorry, but you don't get it? Oh, you do? Okay, so, okay.
Kind of get it.
So I'm not.
Go ahead.
Love myself.
Mhm.
I know, because I can feel bad, I don't know people on.
Well, we reduced it by positive 5 because 5 goes into 15 3 times, and 5 goes into 10 2 times. So we just get a 3 over 2. Yeah, because we had a negative on the top and the bottom. The top was negative 15, the bottom was negative 10. So negative divided by negative is positive. That's why. Yeah. Mm-hmm. So, I'm gonna just wing it. All right. So let's do another y2 minus y1 over x2 minus x1. Let's say that y1 is equal to, I don't know, 6. Let's say that y2 is equal to negative 3. Let's say that x1 is equal to, I don't know, 4. Let's say that x2 is equal to negative 7. I'm just making it up, right? Tell me what to write.
Three.
Okay. Minus what?
-6.
Good. Over.
Over.
Mhm.
-7.
Negative 7. Good.
-4.
Minus 4. Perfect. All right. And then now, what's the opposite of a positive 6? No, no. What's the opposite of positive 6?
Plus, negative plus.
No, no. Positive. The opposite of the positive 6 is negative 6, right? So this is going to be plus negative 6 right here. Then I have my negative 7. What's the opposite of positive 4? Negative 4, right? So it's going to be plus negative 4. And then just go ahead and do that. What's negative 3 plus negative 6? No. What happened? Mm-hmm.
Listen to me, I don't think getting positive 6. I mean, -6.
I'm doing the opposite of the positive 6 here because of the minus sign.
So it's
Mhm.
keep flip.
Keep change,
Oh,
KCC. Right. All subtraction is keep change. All right.
okay.
Right. So negative 3 plus negative 6 is, now we're talking. Now negative 7 plus negative 4, what's that? Negative 11. All right. And then,
Reduce. So
can we?
here,
Okay, reduce it for me.
3. That's all.
Does 3 go into 11? It has to be the same number that goes into the top and bottom, right?
It's
Mm-hmm.
table.
So a negative divided by a negative is a, all right, so my final answer, 9 over 11. All right. Questions on this? So this is like -9 divided by -11. So a negative divided by a negative is a positive. Yeah. So then just make it positive 9 over 11. That's it. Yeah. A negative divided by a negative is a positive. So you could just reduce this to make it 9 over 11. All right. Okay. A negative divided by a negative is a positive. Yeah. Same thing with multiplication. A negative times a negative is a positive. Well, remember that all the fractions imply division. That's what that line in the middle means. All right. So that's why. So we good? All right. Let's take this up a notch. So I want to talk about function notation. So a function is a mathematical concept that is meant to express a relationship between two or more quantities. Students who will go on to study calculus will be expected to become familiar with these mathematical objects. The concept of a function is the main concept that is introduced in pre-calculus classes and is central for any understanding of higher mathematics in many applications. Very roughly, we could think of a function as a rule that takes one quantity and assigns it to another quantity. For our purposes, the quantities involved can be understood to be numbers. So here, we're going to discuss the most basic notation associated with functions. Functions will be given a name, which we will denote with the letter, usually F, but also G, H, etc. If the variable x represents a numerical quantity, the symbol f of x right here will represent the quantity that the function f assigns to the value x. The notation f of x should be understood as a single symbol, all right, which represents a value. In particular, there is no multiplication implied in the notation f of x, all right? Many times a function will be defined by means of an algebraic expression. So for example, we might encounter a function that's described like this: f of x is equal to 3x squared minus 5x plus 4. All right. So what this is saying is that I could plug in any value I want for x. So I might say, oh, what is f of -2, for example, right? And all I'm doing is the same thing that we did before, taking a -2, plugging it in for the x values, evaluating it. And that's it.
And how can I evaluate it?
Just plug it in.
Oh,
Yeah, just plug it in. The same thing that we did before. Yeah. But now I'm showing you a new notation called function notation. All right. But I got you. We're gonna do an example. Don't worry.
yeah.
Hmm. I got you. I got you. It's your first time seeing it. That's why. But don't worry, it gets better. So this just means that for any value of x, the function f assigns to x the value of 3x squared minus 5x plus 4, evaluated with the given value of x. Notice the only variable appearing in the expression 3x squared minus 5x plus 4 is x. The notation f of x is meant to indicate that the function named f depends only on the value of the variable x. So when a function is defined algebraically, using function notation, f of x can also be thought of as the value of f for the variable x. Since x is presumed unknown, the value of f is also unknown, but it is given in terms of x by the given algebraic expression. If the value of x is unknown, the value of f can be also be found by substituting the given value of the variable into the algebraic expression defining f. The notation f of 1, for example, means the value of f when x is equal to 1. Likewise, f of negative 3 means the value of f when x is equal to negative 3. Blah, blah, blah. Here's our question. If I say find f of negative 1, if f of x is equal to x squared minus 3x plus 1, this is what I mean. All right. So I have f of x is equal to x squared minus 3x. Hold on, let me make sure of something. Shoo. Got scared there for a second. Plus 1.
F,
Mhm.
fx equals.
Well, I'm just copying it from right here. Yeah, I'm just copying right here. But because I want to show you that what they're asking us to find is what is f of negative 1, right? So what does that mean? Everywhere I have x, I'm going to put negative 1, right? Everywhere I have x, I'm putting negative 1.
Keep changing. So you have to,
Mhm.
if it's negative in the top, you have to
Mhm.
put a like positive there. Like
What do you mean?
from where you got negative 1. I
Oh,
don't, oh,
the
from
question was asking you. Yeah, 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 yeah. Yeah. But you're right. I could plug in whatever I want. F of negative 2, f of 0. I could do whatever I want, you know? But for this purpose, we're just answering the question, right? So let's do our exponents first. Negative 1 squared is, what's that? Very good, 1. All right. And then I have 3 times negative 1 plus 1. So what is 3 times negative 1? Right. So now I have 1 minus negative 3 plus 1. All right, what's the opposite of negative 3? All right, positive 3, right? So this is going to become 1 plus 3 plus 1. All right, that's the hard part here. What's 1 plus 3?
negative 4.
Close. 4, right? All right, it's a little bit harder. What's 4 plus 1? Mhm. 5. And that's it. By the way, y'all can use y'all, huh? Yeah. By the way, y'all could count y'all fingers if y'all want. You know? Yeah, 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 yeah. I mean, I ain't gonna lie. I'm over here counting my toes because I don't want to show y'all that I'm counting my fingers. You know, I can see them through. I could feel them. You know how you tap? Yeah, I could tap my toes. Nah, but for real, I really still count my fingers and all that. Like, y'all should see me in the supermarket. I'd be like, Mhm. That's the idea of it, right? So this is my original function right here, right? And everywhere I have x, I'm gonna replace it with negative 1 because that's what they want in the question up here, right? They told me negative 1. So because of that, I did negative 1. It says find f of negative 1 right here. That's the real question. Yeah. Yeah. So they gave me a function. The function is called f of x is equal to x squared minus 3x plus 1. And they're asking me find f of negative 1. In other words, what is the answer to the function when x equals negative 1? Right? When x equals negative 1. So f of negative 1. That's what this f on the outside in the parentheses means.
It always has to be
Yeah.
fx.
It could change. It could be g of x. It could be h of x. You know, like it could change. It's just the idea, right? That's the name, and then that the value that's in the parentheses. That's what you're plugging into the
They will
function.
give you the
Yes.
info.
Yeah, they'll always give it to you. Yeah.
That's usual.
Yeah.
F of negative one in
Mhm.
F, then X.
Right.
So that negative one would be.
That's what I want to plug into the function. Right.
Can we try other simple?
Yeah. Yeah, we got one. Hmm? Oh, what's up, man? All right. You want me to scroll down? That's it? Oh, I got you. Okay. Or go up? Oh, I'm sorry. I'm sorry. Sorry about that. Like this? That's good. Oh, oh, I got you. Okay. You're welcome. Hmm? F of negative one equals 5. Mhm. Right. Mhm. I'm sorry? It was negative one. Negative one was the X value. Yeah. Right. Yeah. Mhm. Not fx, f of negative one like this. Oh, wait, hold on. My fault. Like this, f of negative one. That's equal to 5. All right. So let's try this. Let's say I have f of x is equal to 3x squared. Trying to copy the problem from before. Minus 5x plus 4. All right. So let's say that I asked you what is f of 1. What am I going to write? Go ahead. It just means function. Yeah. Yeah. It doesn't have to be f. It could have been g, could have been h. You know, it's just an idea, right? It's a symbol. And then whatever's in the parentheses, that's what I'm plugging in for the x. So tell me what to write here. Good. So tell me what to write. Uh-huh. Uh-huh. Good. Good. Uh-huh. Good. Good. Perfect. And after that, just do a little bit of math, all right? What's 1 squared? Good. This is 3 times 1 minus 5 times 1 plus 4. All right, this is real hard now. What's 3 times 1?
3.
Good. Now, what's 5 times 1? Very good. All right, plus 4. All right. So now, what's the opposite of a positive 5? Oh, close. Give me a better answer. The opposite of positive 5 is negative 5, right? So this becomes 3 plus negative 5 plus 4. And now go ahead, do it. What's 3 plus negative 5?
3 plus negative 5.
Negative 15. Oh, shit, why did I say that?
What is that? It's all right.
Negative 8.
Negative 2, right?
Why?
So you owe me $5 and you give me 3. So how much you owe me now? All right, like that. All right, now what's negative 2 plus 4?
Positive 2.
Positive 2. Very good. And that's it. We're done. All right. Hmm? It's already posted. Yeah. Yeah, if you guys got the lesson, y'all could be doing the homework right now. You know?
They
Right.
might change the number in there, right? They might
Right.
put three, two,
Exactly.
yes, and
Yeah.
all it depends about how like we are.
Right.
So
Just plug it in and do the math.
Yeah.
That's it. Yep. All right. So this is fun. Toot, toot, toot.
All right,
Go ahead.
but,
Okay.
so how did you know to go three positive, -5?
Hold on.
That's the same question I have. What that you said.
All right, go ahead. Say again. How did I know to do positive -5?
So. you see
Because
how-
it's minus. Anytime I have a minus sign, keep change. Keep the first number, change the minus to addition, change and do the opposite of whatever the next number is.
Yeah.
All right. So check this out. If you know how to go from here to here, I'm happy. If you could do that, then I'm happy. You know, this part right here is a trick to get you down to this last part here. But anytime you have subtraction, period.
So any
Right.
is subtraction, anything.
Right. Mhm.
That's
Or
it.
or if you know how to just look at it and do it, I'll take that too. You know, this is showing your work. Yeah. Yeah. That's fine. Like like if I had 5 - 3 and you knew that that was 2, I'll take that. That's full credit. And you could tell the answer with that for that without doing it? Really? Okay. So you just know it's 0? I would show work for this one. Yeah. But the idea here, right? Whenever you have any subtraction, keep the first number, change the minus to addition, and then do the opposite of whatever the next number is. All right. But if you feel confident, like if you could look at it and be like, yo, 8 minus 11, I already know that that's going to be -3. If you could look at it and tell that, I'm cool. All right. You could do that. Yeah. Not with fractions. No, no. Yeah. Fractions get the same denominator, subtract the numerators, then you're good to go. Yeah. Yeah. I'm just trying to make it easy. That's why you see me doing the keep change. But if you feel like your old method works for you and you good, then stick with your old method. All right? No problem there. All right. Let's do another important topic in algebra. Translating. Y'all might find this easy because it's just words, right? So sometimes we want to translate between an algebraic expression represented symbolically with variables, numbers, and operations, and a variable expression with the same meaning. This is most useful when it comes to so-called word problems involving applications of algebra. The first thing to identify in translating an algebraic expression are the variables or unknown quantities, which will be represented with a letter. When there are more than one unknown quantity, or when an unknown quantity occurs more than once in the expression, it is important to distinguish between using the same variable or different variables. Let's look at this example. Translate the following expression into words. All right. So I have 3x squared plus 2x plus 4, and you want to translate that. Like literally write it out in words. The same thing that I just said, you know? So
Example,
like literally like this. So like 3, right? times x squared plus 2 times x plus 4. All right. I was about to write FOR. Y'all didn't see that. All right. And that's it. All right. Translating it from an expression to English and vice versa. All right. Me personally, I hate this because I'm not too good at spelling. Mm. So when I was in fifth grade, right, I was about to get into the spelling bee, and then like got into this argument with like this other student that was there, and they kicked me out. Right. And ever since then, I was like, you know what? Screw spelling. So yeah. This is what I use AI for, because I can't spell nothing. Oh man. Especially some of those hard words like broccoli and stuff. It'd be hard to spell that. It sounds easy, but there'd be double letters in there and stuff like that. Or like phone, that's another one. Like, yeah. All right, so let's translate into an algebraic expression. 5 less than 3 times the number. What y'all think that is? Okay. Keep going. No, keep going. Five less than 3 times the number. What do you guys think that is? Okay, okay. I like that. I like that. Um, mhm. Yeah, go ahead. Mhm. Let me see. Not on this though. Like right over there or something. Yeah. We'll take the markers, whatever. Yeah, if y'all want to write on the boards, go ahead. I ain't writing on the board. Mhm. Well, yeah, go ahead.
Just throwing cats out there.
All of it. Just do all of it. Yeah. Go over.
Yeah, 5 - 3, because 5 less than 3, that's how I interpret it. As less than, it would probably be like
Okay.
a minus.
It's a mix of what y'all like you guys is thinking. All right.
Now, if anyone want to correct, no.
Yeah.
Right, or you mix it.
That's what I'm saying.
Oh,
E times X and then switch it to minus five.
That's it. All right. 5 less than 3 times the number. So you have 3 times some number, right? Less 5. That's it. All right. So you were good. You were good. You can erase it or you can leave it, whatever. All right. So that means that whatever is 3 times the number, you're going to take 5 away from that. All right. So 3x minus 5.
Other example from the book.
Mm-hmm. By the way, your homework got a ton of examples. All right. So y'all, when y'all doing y'all homework, like,
Yeah,
it'll
but
be
here I
easy.
can ask you if I don't understand,
Yeah,
that's why it's different.
that's true.
So, yeah. We can discuss between us,
Hmm.
we can learn each other's.
By the way, it's not illegal if you want to open up your homework and ask a question from there. Why?
I'm so confused on how it's 3 ends.
Right? 5 less than 3 times the number. So whatever 3 times the number is, take 5 away from that.
Time and 3 times come before that.
Right.
Like you see how we have
Yeah.
the collective.
Got you.
But because of the X, it comes before the.
I mean,
right?
technically speaking, if you did this, -5 plus 3 times a number, like technically speaking, that's the same thing.
I'm thinking like that.
That's the same thing. Like this is full credit. I give you 100 for that. That's the same thing. What? Mhm. Exactly. Very good. Yep. Mm-hmm. Yeah. Mm-hmm.
Because, well, you can put,
Yeah.
I was not thought that you can just put anything, but.
It's true. It's true. You could put anything. Yeah. Yeah. My favorite thing is to put C for Chris. All right. So let's look at this next one. Translate the sum of a number and 5 decreased by the difference of 3 times another number and 2.
Twice the sum. Can I try this? But mom, you don't make it in the second. You don't want me to do it. Or one exact, I don't know. So, where do I start off? Where do I start? Start off first. So. Even.
Damn, this hard. This is harder than your homework. I was just doing it in my head, like, yeah, this one is hard. Just do it piece by piece.
Twice the sum, so we know that there's gonna be twice the sum.
Yes, yeah.
Mm-hmm. It's exactly what you think it is.
Nah, if I had a wig, I would have to take it off the fact that I don't say.
All right.
Twice the sum, what is that, isn't that to like the square?
That's it.
Wait,
That's it. That's it. That's it. All right.
better, like what you said?
Mm.
I said 2, 1 to 6, 5 plus 5.
What is it?
5 plus 5.
Um, those,
Mm-hmm.
yeah, the third one. And two.
You got it. Keep going.
6 plus 5. So.
Yeah. Because it's in English, you might see the comma there and all that, but it's all together as one sentence.
It's 10 2.
What do you think and means?
Yes, 2.
3x. You close. You close. There's another word in the front of it that you're not acknowledging. Yeah.
2 times.
Yeah.
2 times 5. Oh, no, 10, because it's twice.
All right, I like the way you think.
No, you like the way she thinks. Alright.
Y'all gonna be really disappointed because y'all homework ain't this hard. Your homework's more like the first question, but if you can get this, you good. Y'all ready for calculus now? Nah, you're not gonna take calculus? Oh man. Nah, it's light, I promise you. Good.
Look at the position you're at.
Mhm.
That's how it's fun.
Nah, it's easy, I promise. Promise you. All right. Twice the sum of a number and 5, right? So this is what I was thinking in my head. 2 times x plus 5. So same thing as you, just reversed, right? decrease by, right, the difference of 3 times another number, let's say 3y, and 2. That's it.
It's not right about the three ball and two.
Nah, it needs the parentheses.
I'm a little more, and if you
Yeah.
don't mind, so can you
Yeah.
I know it's a lot of, I know that,
Mhm.
but please can you give it to us, to me, another time, I still don't understand.
I got
Thank
you. I
you.
got you. So let me explain this one real quick. So this twice, right? That's the 2 in the front. That means I'm going to double whatever's about to come after that word, right? So that's the 2. The next part is like the next part is just the sum of a number and 5, right? That's just this part here. Yeah,
So mean sum of a number and five mean x plus, it doesn't matter,
right,
8, 7, and 8.
right,
X plus 6, 7, 5, in this case,
right.
it's 5. So, okay, I got it.
So
That's the same
sum
part.
means addition. It means add, right? Even when you're doing it in Excel, right? I know we don't really talk about Excel here, but there's a function in Excel called sum, and literally what it does is it adds 2 numbers together or many numbers together, right? That's it, right? Decrease by. As soon as I saw that decrease by, I knew that was a minus, right?
Chris, okay.
Yeah. So this right here, right? Decrease by. As soon as I saw that, that's that minus sign right here. You know, decrease by. But then they had the difference of 3 times another number and 2, right? Now, because it's decreased by, I knew that that had to be a parentheses right there. You know, like this next whatever's coming after this decreased by, that's going to be lumped together, so to speak, you know? So when they said the difference, I knew that whatever 2 numbers they about to tell me, they're gonna be minused, right? Whatever 2 numbers or whatever comes after is gonna be minused. And then they just dropped the 2 numbers on me, right? So I had the 3y, 3 times another number. Keyword there was another number, so that means I can't use the same variable, right? The x is gone, so now I got to use y or k or j or whatever, you know? Some other number. And then they just dropped the second number on me. All right, which was 2. And that's it. Again, because it's like it's more than one term that they're giving me, a first term and then a second term. So that's why it's the English why that's there. Hmm. Make sense? I promise your homework is not this hard. You guys can look at it right now if you want to see. Hmm. Yeah. The homework looks more like the first example. This one was just for fun in class. And no, I'm not putting this on your test. Mm-mm.
And
Mhm. Huh?
and then like, are you able to?
Oh no, like the topic is gonna be on the test, but not a question like this. More work for you is more work for me. Mm-mm. Got to work smarter. All right. So let's summarize a few common issues to watch out for in translating between algebra and words. Make sure to repeat the same unknown quantity with the same variable name, no matter how many times it appears in the expression, while different unknown quantities should be represented by different variables, right? Subtraction has several verbalizations that reverse the unusual left to right order. subtract something from something else, or something less than something else, both reverse the unusual left to right order, while something decreased by something else, or the difference of something and something else, maintain the usual left to right order. Grouped operations are often implied. For example, by phrases like the quantity of, but they are also expressed in phrases like three times the difference. All right, so you just got to be careful of that. But it's in your homework. Y'all check it out. It's mad simple. All right. Let's see what else. Yeah, I could probably do something. 1 second. All right, I'm gonna leave it up to y'all. All right. I kind of want to go on to like tomorrow's lesson and start it right now. But do y'all feel tired and y'all want to dip early? Up to y'all. How y'all feeling? Huh? You want to leave early? All right. So let's call it at that. Come sign attendance if you ain't signed it yet. All right. I'm me personally, I'm going over the tutoring right now. So if you guys want to follow behind me, y'all could come and take a look at it.
Yeah.
Um, Pantry is downstairs. They don't close till like 6:30, so y'all have time if y'all didn't get a chance to go earlier. Y'all could go sign up right now and then just pick up the stuff tomorrow. All right. Bring a cart, bring bags. All right. If you have a car, that's even better. All right. All right. Can I take this down? That's cool.
This too.
Appreciate y'all. Yes.